So we'll, as I said, we finished the lecture, right, on latches and flip-flops. So we'll do tutorial. This tutorial shouldn't take long, and then we will start a new topic or the next topic, which is related. Basically, it's about the use of VHDL to describe sequential circuits. So now we will talk about more on sequential circuits. So we'll start the first question. The question is about the Q. So to sketch the Q waveform of a gated SR latch. So we have an SR latch gated. So as you know, I mean, when we say this, you should know what is an SR latch. What does it have as an input and what does it have as an output? So we know that SR, it has S, it has R, and we have enable as well, right? Because we said it's gated. And then we have all of them, they have Q and Q bar. The question we ask about Q, but Q bar is just the opposite of Q. And of course, you need to know how does the SR latch work. I mean, when we have 0, 0, I mean, the truth table, basically. 0, 0, 0, 1, 1, 0, and then, 1, 0, and then 1, 1. So Q, usually we talk about the next Q. What will be the next Q, depending on the current inputs, S and R, and we may need to know as well the previous Q. We may need to use the previous Q, the previous value of Q. Right, for SR latch, we say 1, 1, for the case of 1, 1 is not allowed. So we shouldn't have this condition. 0, 0, no change. So this condition or this case is no change, so we should get Qn. So if Q was 0, it stays 0. If it was 1, it stays 1. No change, basically. We don't change, the output doesn't change. And then 0, 1 and 1, 0 is set and reset. Set, it means we put it to 1, so the output will be 1. And reset, so when R is 1, it's a reset. It means we push the output to 0. I'm just trying to repeat again what we did, just to refresh your memory and to work as well to use them in this exercise. Right, so and then we gave you this scenario. If we have those waveforms for En, S, and R, so what should be the output Q? Of course, we need to mark the important points or times in our waveforms. Those are important for En when En is 0 and changes to 1, or when it's 1 and changes to 0. So those are important times that we need to consider. And then, of course, we need to observe S and R. En is very important. When En is 0, nothing will happen. When En is 1, then we use this table. So this table works for En is equal 1. For En is equal 0, no change, nothing happens. Right. We say here as well, the initial condition of the output, we say if the output is initially reset. So reset, which means it is 0, starts from 0. So the output Q, so let's say this is Q, so starts from 0. This is 0. And then we start observing the waveforms, and we found the next Q. Now, from here to here, En is 0. This means we don't care about S and R. Right? So I don't need to observe S and R from here until here, because so Q stays as it is, doesn't change. Now at this time, I need to consider S and R because En is 1, right? So at this time here, En is 1, I need to consider the S and R. So what is S? S is 0. R is, oh sorry, S is 1 and R is 0. So what does it mean? 0, 1. S set. So which means it goes to 1.
1, yeah.
So we need to go to 1 here. And stays 1 as long as S is 1 and R is 0. But here we have a change. So this is another important time that we need to consider here. Now we have 0, 0. At this time here, En is still 1, which is fine. So we can consider S and R. S is 0 and R is 0. What does it mean? It means no change. So again, it stays 1 because it says no change for this time. And then from this point here, this one until here, again we have En is 0. And again, during this whole time, I don't care about S and R because En is 0. So again, there is no change. It will stay as it is, as it was. It was 1. You see here, the Q is 1. It stays 1. So no change again. And then we have En is back to 1 here. So we S and R. So S is 0, R is 0 until here. So this is another important time as well that we need to consider. And here as well. So for this small time here, it's 0, 0 again is no change. So it stays 1. And now N is 1 for this. S is 0 and R is 1. So which means we should have a reset here. Reset, which means it goes to 0 until this time here. Right? And then it goes 0, 0. 0, 0, it means no change, so it stays 0. So this should be our Q for this SR latch, which is gated. So basically we need to observe the most important one here is En, because En will really affect the output. So if it's 0, the output will not change. We don't care about S and R. So it's like the priority is for En. We check En first. If En is 0, we don't care about S and R. And the output doesn't change. And then if En is 1, then we check S and R and we use the truth table. And we update the Q according to the truth table. As simple as that. Right. I hope this is clear. Next question. This is a D flip-flop. So the first question was an SR latch. This is a D flip-flop. D flip-flop, and we said it's minus VE edge trigger. We use minus VE. So I mentioned this minus VE or negative edge trigger, minus VE or negative or falling edge. They all have the same meaning. So this flip-flop works on the falling edges, not on the rising edges of the clock. And this is a simple D flip-flop. It just has the, and you know what is a D flip-flop. So we have D, we have clock, CLK, and then we have Q and Q bar. And we say here for the D flip-flop, it's easier than the previous one. This we said it works with falling edges. So I will just mark the falling edges here. So those are the falling edges. On those falling edges, I will check D, and then Q follows D. As simple as that. Q follows D on the falling edges. Again, so did we say here it's initially reset? So again, it starts with 0, initially reset. So we start with 0, we go until the next falling edge. So, or this is the first falling edge. Now, what is D? D is 1, so Q should be 1. until the next falling edge. And do you see D is changing here, but we don't care because we just check it on the falling edge. Even if D is changing in between, we don't care. We only check on the rising edge or the falling edge, depending on which edge we work with. So in this exercise, we work with the falling edge. Next falling edge, what is D? D is, here D is 1. So it stays 1, right? Until the next falling edge. The next falling edge, what is D? D is 0. So it stays 0. The next rising falling edge, D is 0. So again, it stays 0. And that's it. So for this scenario, this should be the output Q. I think the flip-flop is very simple. You just look onto the rising edges or falling edges, and then Q follows D. Next one, question 3. This is a JK flip-flop. We say positive plus VE edge trigger, which means positive edge trigger. So I need to mark the rising edges. Those are the rising edges here, right? Is this clear? And then what did we say about the output is initially preset? So you need to be careful. We said it's initially preset. This means it starts with 1. So the output starts with 1, Q, because we said it's preset. So reset starts from 0. Preset starts from 1. You may find as well clear. So clear or reset is the same meaning, 0. Set or preset is the same meaning. It means 1 as well. We start with 1. Here we said preset, so we start with 1, and this is a JK flip-flop. Of course, you need to know the truth table for a JK flip-flop, and you should know what is a JK flip-flop. So JK, we have J and K, we have clock, and we have Q and Q bar. Again, here we just want to draw the Q bar. This is very similar to the SR, except for the last case. So Qn plus 1, 1, 0, 1, 1. So this is no change. This is JK is similar to SR, so it's a reset. So it's 0, 1, 0 is 1, and 1, 1 is the opposite, Qn bar. So the previous Q bar, or the opposite of the previous Q. We did this in the lectures. Yeah, I'm just trying to refresh your memory here. Right. And that's it. So now we just follow the waveforms, and we look on the rising edges. So we need to check J and K here. We need to check J and K here at this time. J and K here. J and K. And then J and K at this time. And that's it. So here it's 0, 1, 1. Here it's 1, 1. Here it's 0, 1. Here it's 1, 0. And here it's 0, 0. And that's it. I just need to follow the truth table. So it starts with 1, and then the first rising edge is 1, 1. So what do we do? What will be the next value?
It would be
Q?
1.
0.
Yeah, 0. 1 Qn bar.
0. Good. So it's Qn bar, the previous Q bar. This is the previous Q. Now we are talking about the current one is here. We are here. So the previous one is 1. So it will be 0. Oh, sorry. So we go to 0, and it stays 0 until the next rising edge. next rising edge is 1 1, so it's again it's Q bar, so it's a toggle. We call this toggle operation. We invert. It's 1, and then 0 1. What do we do when J is 0 and K is 1?
It's goes down
It's
to 0.
Reset. So 0.
It's like a reset, so it goes to 0. Good. And then 1 0. What do we do? Is a set.
It's a set, so it goes down.
So we go to 1. And then 0 0 is 0, is nothing. So no change. 0 0 is no change, it stays as it was, and then this is, and that's it. So we have all cases here in this scenario. Right. Okay, good. Next, now we have a JK flip-flop. Again, this is a JK flip-flop. And then we work with, we say it's initially cleared. So here we say I use the word cleared, so which means 0. So clear reset is 0, set preset is 1. So again, here we start with 0. So we start with 0. It's a JK flip-flop, and but this one, as you can see, this one has a preset pin. Do you remember in the last in one of the slides we talk about you may find JK flip-flops which they have, or flip-flops which they have an extra pin. So we have J, we have K, we have clock, we have Q, we have Q bar, and you might have this preset pin. So this preset pin is used to, when we put 1 here, we don't care about the clock, we don't care about JK, the output is always set to 1. So we force, so this output is used to force the output to 1. Right. So whenever there is a 1 here, at exactly the time when it goes to 1, the output will change to 1. It's a preset. Or if it was a reset, because we have preset and we have clear or reset, then it goes automatically, it goes to 0. We don't wait for the next rising edge. We don't care about J. We don't care about K. Right. So this one, again, did we specify here if it's falling edge or rising edge? I think we didn't specify, so which means we work with the normal one, which is the rising edge.
It says positive edge trigger though.
It says positive edge trigger, yeah. So if it is not mentioned, you just work with the positive one. So we'll mark those positive edges. So this is the first thing that I need to do. And then, as long as preset is 0, then it's fine. I will look for J and K. So here, and this is very important, preset here, this time, at this time, definitely Q should be 1. I don't care about the, I don't know what was the previous value for Q, but at this time it should go to 1, because preset is 1. Do you understand what I mean? Yeah. So this is 1. I know in advance that this should be 1. Now I start with 0 here. Preset is 0, so it's fine. I will just look for, check J and K. J is 1, K is 0. What does it mean?
It goes to 1.
Huh?
It's
J1,
1.
it's set. So we go to 1. Good. We said we start with, did we miss a question? Oh yeah, we missed a question here. I will come back to this one, yeah? So don't forget what we talk about here. This is related to the previous question. The same question here. We said repeat A. So we need to repeat this question, this A, for a pulse triggered JK flip-flop. So this means this will change. I'm getting this. Now we say a pulse triggered JK flip-flop. This means, what does it mean, pulse triggered? Which means we consider both edges, right? Let's say I'm trying to find a different color. So we consider the falling edge and the rising edge. So we read the values of J and K on the rising edges, but we don't update the Q until the next falling edge. So the values that we read are the ones that I kept them here. I marked them before. So those are the same values that we are going to use for J and 0, sorry, 1, 1, 1, 1 again, and then 0, 1, and then 1, 0, and then 0, 0. Those here. Those are the values that we will consider on the rising edges. But we don't update until the falling edge. So basically, we will get the same waveform shifted half clock cycle. So now if I will draw, we start with, we set preset. So we start with 1. Right. Now this is the first rising edge here. At this edge, I will just check J and K. J is 1, K is 1. What should be Q? Q should be the opposite of the previous one. So it should be Q bar. It should be 0, but not here. I'm not going to do 0 here. Like at what, if I do it here, then this means it's a positive edge triggered. It's not pulse triggered. So I don't do it here. I will just continue, leave this as it is until the falling edge. Then I will update it here. Here it goes to 0. This is the difference between positive edge triggered and pulse triggered. Now I will continue. Again, I have 1, 1 here at this positive edge, but I'm not going to update here. I need to continue to 0 until the next falling edge, and then I will update. So this should be 1. It's a toggle operation. And then again, we check here what is J and K. J is 0, K is 1. Reset. I will do it on the next falling edge, which is here. And then I will keep it 0. And then we check here again. This is 1, 0. So it's a set. It goes to 1. And then here 0, 0 is no change. We keep it 1. So if you compare the two waveforms, you will see it's exactly the same shape, but this one is shifted. Is the other one shifted by half clock cycle? Right. I hope this is clear. So back to this one. This is another, as we said, it's a JK flip-flop which has a preset. A preset forces the output to 1, regardless of the value of J and K or the clock, rising edge or falling edge, we don't care. Whenever there is a preset, then it goes to 1. Right. So we start with 0, and then here we have J is 0, K is 0. J0, K0 is a reset. So which means we go to 0, right?
J is 1.
Sorry, it's a set or a reset. J is 1, K
Set.
is 0. It's a set, so we go to 1. Yes, correct. Good. And stays 1 until the next rising edge. We still have P is 0, so it's fine. The JK will work as normal. And then we have 0, 0. No change. Right? No change, it means it stays 1 until here. And then we have 1, 0. 1, 0, what does it mean? It's a 0, 1. 0, J is 0, K is 1. It's a clear or a reset. So it goes to 0. And then here, at this time, we have a preset. I don't need to leave this until the next rising edge because I have a preset 1 in between. So it goes to 1. It should go to 1 here at this time. Stays 1 as long as preset is 1. And as long as there is no rising edge. So it stays 1 until the next rising edge. Next rising edge, as you can see, the preset is 0. So now we can check again J and K. J and K is 1, 1. So it's a toggle. We go to the opposite. And this is the output Q. It's clear. So it's a normal JK flip-flop, but we need to check the preset. If there is a preset, we forget about the clock, we forget about the J, we forget about the K. It just goes to 1. If this was a reset or clear, then again we forget about all other inputs, J, K, and clock. We just go to 0 whenever there is a clear signal. Right. Last question. We did clock divider, right, in the lecture, and if you remember, I said we with a D flip-flop, by connecting the D flip-flop this way. So this is Q bar, this is D, and of course you have clock. This Q, the clock here, this will be how the frequency of the signal Q here will be half of this one, right? And we said we can do it as well with a JK flip-flop by just connecting. So this is J, this is K. So we have Q bar. And then by just connecting the J and K to 1. So we always have a toggle operation. If you do this, I will get a clock divider. Divide by 2. So this is divide by 2. If I connect 2 together, so if I take this question, it asks you to use the D flip-flop from the previous question. We did a D flip-flop here, right? And then we did this one as well, the JK. So assuming that you have one JK, one D flip-flop, and we ask you to use them to get a clock divider that divides the frequency by 4. So we want to divide by 4. You know how to do it, divide by 4, if you have two D flip-flops, right? We did it. So to D flip-flop, I will just place another D flip-flop here. So this goes to D, Q bar, this is Q, and I will just take this one, and this will be the clock for the next one. So this divide by 2, and then this will divide by 4. So the frequency here, or the period, it will be 4 times the period of this original signal here. If I want divide by 8, I will connect another one, and so on. I do the same for JK flip-flop. Now we told you you have one JK, one D flip-flop, and we want to get the divide by 4. I think the answer is easy, right? It's very simple. So I'll just place the JK flip-flop here, JK. This goes to 1. This is Q bar, and we just connect this to the clock. If this is this divide by 2, so if this is this original clock divided by 2, then this will be this one divided by 2, which means is the original clock divided by 2 twice, so which means is the original clock divided by 4. Is this clear? The JK flip-flop that we have here has P. So what should we do to this P? Be connected, or it should have something. So what should we do to this P to get this clock divider to work? Should we do to P?
Should be connected to 0.
Yeah, 0. That's it. Good. Excellent. So this P should always be 0. So which means we will not preset at all. And that's it. So this will work as a clock divider. Good. Excellent. That's it for this tutorial. I think we will do more in the next tutorial when it comes to this, describing, those flip-flops in VHDL, or circuits that will include flip-flops, how to describe them in VHDL. And then we will design as well, we'll show you how to use those components to design some special circuits. And this will be the last topics, basically, in our course. Right, so that's it for the tutorial. I will post the solution after this lecture.